Let's calculate the electric field due to a finite line of charge. So for instance, a wire of length L that has a total charge Q. I want to know what is the electric field at point P, which is a distance A to the left of one end of the wire. Notice that in this case, we can't use Gauss's law to calculate the electric field at point P. There is no Gaussian surface that we could choose that has appropriate symmetry, where all of the electric field on the whole surface would have the same value. So we're going to have to take a different approach to finding the field in this case. We're going to treat the line of charge like a collection of point charges. We're going to find the field of each of those point charges individually and then add them up to get the total field. This is equivalent to integrating. Let me show you what I mean. Let's take an arbitrary little piece of this wire that has some tiny little width, dx. And I'm going to say that this particular piece of the wire is a distance x away from my point P. Because my piece is so small, I'm not going to worry about the width of the piece. I'm going to say the whole thing is a distance x away from point P. I'll treat that little piece of the wire like a point charge. It creates some field at point P, which is going to be pointing to the left. Let's calculate the field due to just that one little piece of charge. I know how to write down the field of a point charge. E is equal to 1 over 4 pi epsilon naught times Q divided by the distance squared. In this case, since my field is for just a tiny little piece of the wire, I'm going to say this is dE, the infinitesimal contribution to the total field made by this infinitesimally small piece of wire. And I'm going to call the charge of that piece dQ. It's just some tiny portion of the whole charge. So what is dQ, the charge of my little piece? If the whole rod has a charge Q and a length L, and if that charge is uniformly distributed along the rod, which in this case it is, the charge per